Hi, and welcome to the Product Design Show. I'm Allison Tupperwine.
And I'm Vince Penman. In this episode, we're going to look at how advances in software allow engineers to design boats that are lighter, faster, and even fly. Well, sort of. 70% of the Earth's surface is covered by water, so it's not surprising that boat design is one of the earliest forms of engineering. Today, boats come in a huge variety of shapes and sizes, but from the biggest ocean liner down to the teeniest rowboat, the basic concepts behind designing a boat are the same, and it all comes down to basic physics. With any boat, there are certain forces that have to be balanced. The supporting force of the water, or buoyancy, must be greater than the weight of the boat. The thrust from the propulsion system, like a sail, a paddle, or motor, has to overcome the resistance force of the boat's surface moving through the water, or drag. Also, to make sure your boat doesn't tip over in the water, the weight has to be evenly distributed around a point called the center of buoyancy, which is usually located about halfway between the bow and the stern. Shifting weight rapidly away from the center buoyancy can result in the boat capsizing, which, while dangerous in large vessels, is a gold standard joke for any 80s camp movie.
Nowadays, advances in software allow engineers to create better designs that make boats more streamlined, lighter, faster, and more efficient. For example, Voxdale, a design and engineering firm in Belgium, uses advanced modeling software, like PTC's Creo Elements Pro, to design boats for its clients. Software allows engineers at Voxdale to not only see how the boat will look in 3D before it's ever manufactured, they're also able to virtually test how it will react in the water using computational fluid dynamics, or CFD. That way engineers can be sure that the boat they've designed not only has great form, but is also optimized for function before ever building it.
The use of computer modeling programs and CFD software lets engineers create radical new boat designs that previous generations of engineers would have never thought possible. Some of these designs even allow boats to virtually fly over the water. One of these designs is the tunnel hull boat, which incorporates a wing, or airfoil, built right into the hull of the boat. The wing generates aerodynamic pressure that lifts the boat out of the water, allowing it to go faster. Now, why would lifting a boat out of the water make it run faster? Well, since the water is about 1,000 times more dense than air at sea level, the less of the hull that comes into contact with the water, the lower the drag force on the boat.
Another popular design to lift boats out of the water is called a hydrofoil. Like an airfoil is a wing that flies through the air, a hydrofoil is basically a wing that flies through the water. When a boat moves through the water, most of the energy is used to move the water in front of it, out of the way, and to counteract the drag of the hull's surface on the water. Using a hydrofoil to lift the hull out of the water means that the boat only has to overcome the drag on the foils and not the entire hull. And again, less drag means a faster boat. Nowadays, airfoil boats are used as commercial passenger ferries, as an alternative to slower traditional ferries. You can hop on a hydrofoil to zip across the Aegean Sea to various Greek islands, between Korea and Japan, and in China between Hong Kong and Macau.
Boat design demands that engineers work together on elements like surfacing, parts, and big assemblies. Now, I know it's hard for us engineers to talk and socialize, but don't worry, I have something that might help. You can download an excellent article on the best practices for concurrent engineering at ptc.com/go/ce-tips.
That's a wrap for this week. If you have a suggestion for a product design you'd like to see on the show, please send it to productdesignshow@engineering.com. Next week on the Product Design Show, we'll bring you some surprising new design turns on that venerable mechanical device, the screw pump.